Hello. All right, let's go. Hey, if you're not subscribed, subscribe, please. And there's a free PDF in English and Spanish. You can download that and perform these problems. Have a great time with them. Come on back, see how you done. Don't forget to give me a like, a big thumbs up, and tell your friends. Aight? Okay, here we go. Make sure those electronic devices are put away and you are focusing on yourself. This is Algebra 1, Linear Graph Analysis, Practice Worksheet. We're going to refer to this given graph. Notice this graph is measuring the days of flowers growing, that's your input value X, and the height of the flowers in inches. That's your output Y. So that should make sense, right? As the spring and summer go, days are going by, what happens to your flowers? They grow taller. Okay, notice we have a minimum and a maximum value. So let's talk about this. Describe in words a possible scenario for the graphs above. Well, these are the heights of my flowers. After days growing, right? That's it. I just used the X and Y axis to write that. Ooh, and then we're going to make a little flower. All right. Okay, what was the initial height of the flower? Okay, now this is the initial height. The y-intercept is always the initial value. So your initial height is 5, and notice we're measured in inches. So 5 inches. What is the average rate of change? That means the height in inches per day. Well, to find your rate of change in a graph, you want to find these things called lattice points. Lattice points are points that go where the grid intersects. So that's a lattice, right? Lattice point. They're all lattice points here. This would not be a lattice point. This is not a lattice point because it's got to be where the grid intersects. So from here to here. Notice I go up 5. So that's a positive 5. Always go from left to right when you're finding that rate of change from a graph. And also notice the units of measurement are 10 on the X. So as I go up 5, I go over 10. So it's 5 over 10, and you should reduce your fractions. So that's 1/2 inch per what? Per day. Okay, there it is. What are the minimum and maximum input values? The input values are X. So the minimum X is right there. The maximum X is right there. So the minimum is 0 days. That's the day you planted them, right? And they were 5 inches tall. The maximum is 80 days. And notice at that time, they were 45 inches tall. What is the minimum and maximum output? Okay, so the output is the Y. So it's there and there. So the minimum is 5 inches. Yep, inches. That is the day, oh my goodness. That is the day you planted them. So 5 inches. And then the day when they stopped growing, which was 80 days later, they were 45 inches tall. Okay, according to the model, how many days were the flowers growing? Well, they started at 0 days and they went to 80 days. So the flowers were growing for 80 days. And then I don't know what happened. They died, we cut them down, I don't know. Write a function that associates the height of the flowers, h of d. Okay, so that's my output. So h of d equals my rate of change, right? Remember, you're writing y equals mx plus b because it's linear. The m is your average rate of change right there, so 1/2. Your input variable is that variable, whatever in the parentheses. It's the height of the flower in terms of d. So d is represented by days, so that's the height based on days, plus the initial height. Well, the initial height was 5 inches. Boom. How tall were the flowers after 60 days? All right, well, I'm going to go up to my graph. And I'm going to find 60 days. There it is. And I'm going to go up and over. They were 35 inches tall. Make sure you do unit of measurements on all of these things. How many days did it take for the flower to reach a height of 25 inches? All right, well, let's go. Oh, I'm sideways. Let's go back up to the graph. Now I'm going to go to the y-axis and find 25. Send it over to the graph. Woo! And then straight down once you hit the graph. Looks like 40 days. How many days did it take for the flowers to reach a height of 37? Well, now that's a little hard for me to look on here. I mean, I could approximate, right? Sorry, 37 days. I could approximate exact. So to get it exact, I'm going to go to my function, and I'm going to let my output be 37, right? Because the height is the output. So I'm going to say h of d is 37, and that's 1/2 d plus 5. Solve this equation for d. Subtract 5, subtract 5. That's why it's important to know what the input and output mean. H of d is the height of the object, the flowers in this case, and d is the number of days. That's 32 equals 1/2 d. Now I'm going to divide by that number in front of d. Divide by that number in front of d. Don't forget, when you divide, you got to put it in parentheses. And you end up getting 64. So that's 64 days. All right, is the growth model above continuous or non-continuous? Well, if you can draw the entire graph without taking your pencil or pen or highlighter off, then it's continuous. So if there's no gaps, it's continuous. That is continuous. C-O-N. All right, good job. Let's keep going. Okay, now we got bags of cookies sold and profit generated. Describe in words a possible scenario. Well, right, we're talking about the input is number of bags of cookies sold. The output is the amount of money you generated. So it's money generated or profit generated, either one, by selling bags of cookies. That's it. And there's numerous ways to state this. Numerous. But you really want to look at the x and y and just put that in a sentence. All right, let's keep going. Okay, so now it says, what is the initial cost for materials to make the cookies? Well, notice right here, I sold 0 cookies, and it's -20. Well, -20 represents profit or money. So it must have taken $20 to make the cookies. What is the average rate of change? Okay, now I got to look for those lattice points, right? You can find them, like there's one, and there's one. So I go up 10, 20, and over 5, 10. So it's 20 over 10. And that reduces to 2. And remember, we're talking about dollars. What are the minimum and maximum input values? Well, the input is X, so the minimum is right there. That's 0. The maximum, by the way, 0 what? Bags sold. And then the maximum is right here. Ooh, we sold 80 bags of cookies. Let's go. 80 bags. They must have been good cookies. All right, what are the minimum maximum output? Well, we already knew that $-20 was the minimum Y, right? And the maximum Y is up here. We got to follow this maximum point over to the Y-axis. We made $140 off of selling some chocolate chip cookies. That is good stuff. All right. According to the model, how many bags of cookies need to be sold to break even? Well, break even means we are at 0. So we had to sell 10 bags. All right. Write a function to associate the profit generated, P of C, where profit of C is the profit, or P of C is the profit, and C is the number of cookies or bags sold. Notice your rate of change is 2. Well, that's your slope. And then C is your input variable because it's got to match that. That's your input variable. The whole thing represents your output. Your initial value is minus 20. That's your y-intercept. So that's done. What was the total profit earned? Well, that was the maximum, right? That was the maximum. So we made $140. How many bags of cookies were sold to generate a profit of $70? Well, here's $70 right here. We had to sell, looks like 45 bags. How much profit was generated after selling 46 bags? Hold on now. That's just one more bag than that. So that's just $2 more than that. Let's go. I love that common sense. $72. Is the growth model a continuous or non-continuous? Well, notice how it's dashed. That's because every bag of cookies is its own ordered pair. You can't have 10 and a half bags sold. You can't sell a half of a bag. So this is non-continuous. It's just a bunch of ordered pairs that have a linear pattern. So it's non-continuous. If you can't sell half of something or half of something doesn't make sense, then it's non-continuous. All right, let's move on. Athletic events. All right, 8 a.m., 7 to 9-year-olds go. If it's in dark blue, that means it's included. If it's in yellow, that means it's not included. Okay, that's when it ends and they begin. At 9, they end. 9-year-olds to 11-year-olds begin. Right? Okay. Describe in words a possible scenario for the graph. Well, we have age of athletic participants and athletic events. So age of athletic participants and starting time of event. Events. All right. B, what is the starting time for the ages 9 to 11? Well, here's ages 9 and 11. So that goes there and there. They started at 9 a.m. What range of ages started at 11? Well, here's 11. And they started at what age? So 13 to 15 years old. Make sure you do those unit of measurements. What are the minimum and maximum input values? Okay, well, input is right here. So the minimum is 7. The maximum is 17. That's 7 years old and 17 years old. All right, what are the minimum and maximum output values? Well, the output values are here. Start at 8 and ends at 12. Okay, so 8 a.m., 12 a.m. p.m. All right, according to the model, what time does a 16-year-old's event start? Well, 16-year-old, they start at 12 o'clock, 12 p.m. According to the model, what time does 11-year-old's event start? Well, here's 11. Oh, they don't start there. They start up here, right? Remember, blue is included, yellow is not included. So they start at 10 a.m. According to the model, what time does an 8-year-old's event end? Here's 8. They end at 9 a.m. You know what? I'm going to go back up here. I don't think the maximum is 12 p.m. I think the maximum is going to be 1 p.m. because all of them go for an hour. So I'm changing this to 1 p.m. All right? I'm going to change this to 1 p.m. It starts at 12 but goes to 1. Okay. What time do you think the athletic event will begin? Well, it begins right there at the y-intercept. That's 8 a.m. What time do you think the athletic event will end? Well, I think it's going to end at 1, because if they start at 12 and all of these go for an hour, then that means that goes for an hour, and it's going to be 1. So I'm going to say 1 p.m. Is the growth model above continuous or non-continuous? Well, notice I go like this, but then I have to jump and jump and jump. So that is non-continuous. I cannot draw the entire graph without lifting my pencil. Continuous. All right, good job. Last one. You're doing great. Keep it up. Refer to the given graph to answer the following questions. The graph is a model substance cooling over time. Okay. Label the turning points, including the initial point and ending point A through F. Okay, so there's A, there's B. This is a turning point. So turning points are where it makes a turn, right? D, E, and F. Okay, that's done. Is the substance heating or cooling? Well, notice you went from 160 degrees Celsius all the way down to, what, 20? So it's definitely cooling. What is the horizontal axis measuring? Horizontal is left and right. It's measuring time in minutes. What is the vertical axis measuring? Well, the vertical axis is vertical, up and down. It's measuring the temperature in Celsius. What are the minimum and maximum input values? All right, well, the minimum input is 0, and the maximum is 25. Minutes. What are the minimum and maximum output values? The maximum is 160. The minimum is 20. And don't forget unit of measurement. 160 goes here, Celsius, and 20 goes there, Celsius. What is the average rate of change for segment CD? Okay, well, here's segment CD right here. So the average rate of change is going to be change in Y over change in X. So I'm going to measure this distance divided by this distance. So from here to here, notice I'm going down by tens, right? So 10, 20, 30, 40, 50. So I went down 50. This is measuring in ones. 1, 2, 3. Whoa, I better start over. 1, 2, 3, 4, 5, 6, 7, 8. All right? So it's negative 50 over 8. That reduces to negative 25 over 4. And notice what we're measuring. Celsius per minute. So it's decreasing by 25 over 4 Celsius per minute. What is the average rate of change for segment BC? All right, well, segment BC is right here. Notice how it's flat. There is no change, right? From here to here, the elevation is the same. So that means your slope is 0. 0 Celsius per minute. I should do that, that, and that, and that. All right, ooh, I'm all crooked again. What is the average rate of change from point A to F? Oh, that means from the beginning to end. All right, so what I'm measuring here is I'm going to measure this rate of change. Okay, I'm going to measure this. I'm going to measure this rate of change. The average means from that point to that point, not taking into consideration what happens in between. So, notice the change from there to there is from 160 to 20. So it's down 140. From there to there, it's a positive 25. So my slope from A to F is negative 140 over 25. Put that in your calculator, turn it to a fraction that is in reduced form, and you're going to get negative 28 over 5 Celsius per minute. How long did it take for the substance to have a temperature of 60 degrees Celsius? Whoa, 60 degrees. Okay, I'm going to go up here. I'm going to follow 60 degrees over. Right there. I'm going to follow it down. 21 minutes. Convert 60 degrees Celsius to Fahrenheit. Okay, well look at this. The C represents your 60. So Fahrenheit is F 9/5 times 60 plus 32. In the United States, we use Fahrenheit. Pretty much everywhere else on the planet, they use Celsius. So F equals, I'm going to go ahead and just put all that in my calculator. 9 divided by 5, open a parenthesis, 60 plus 32. 140 degrees Fahrenheit. That's hot. All right, that's it. That wasn't bad. That was fun, actually. I enjoyed that. Hope you did as well. Stay strong. Remember to clock it and lock it, my people. Don't be your own worst enemy. Get your devices at your face and focus on your education. All right.